Question 1. Sound waves are longitudinal. Draw a representation of a longitudinal wave in the tube below, labeling the wavelength, a compression, a rarefaction, the direction of particle vibration, and the direction of energy propagation. So I find the best way to draw these is to use vertical lines. You can use dots, but you have to draw so many that it would be difficult. So if I talk through how I think about it in my head to start off with. So what I'm going to draw first is not a good representation. So these lines are approximately evenly spaced inside the tube. So this might be how I would represent the air inside the tube if there wasn't a sound wave going through and the pressure was uniform at all points. Now, once I've got this, what I want to do is to show that in some parts the air particles get closer together and in other parts they get further apart. So on one note, it's relatively easy to think about moving these. So if I move these two in quite a long way, I immediately create a compression. I'm going to move the next ones along in a little bit, and then I'm going to leave the next ones alone. So this one here is now going to be my rarefaction. So counting across, I moved two of them. So these two over here, I'm going to need to move as well. I'm going to move this one so it gets much closer, and then this one so it's a bit closer across in this direction. And then on the other side, this one here is going to become my rarefaction. So this one moves much closer and this one slightly closer. And so by drawing these lines and moving them around, hopefully you can see I've created regions where there is a much higher pressure than normal. These are, let's label in a different color, are compressions. I'm just going to do them as C's on my diagram here. I'll say underneath C is a compression. And R's, I'll put them below as well, are here with the R's being for rarefaction. Then labeling on my other properties, my wavelength should go from one compression to the next. Symbol we use for wavelength is a lambda, so I'm going to use that. And then in terms of the particles, which way they're vibrating and which way the energy is propagating, we saw I had to move my lines left and right. So the direction of vibration is an oscillation backwards and forwards in this direction. So each particle will be vibrating left or right, while energy moving through the system can either be going to the left or the right, but it has to be one of the two. Because I read right to left, I usually think about it traveling right to left. So I'm going to label this as the propagation, the direction that energy is moved in the wave.